Hello everyone, our work is on knowledge distillation techniques for singing voice detection. Singing voice detection is a binary classification problem of identifying singing voice in a audio segment of length 100 to 200 milliseconds. Among existing work, the two most popular methods are based on deep learning. One is a CNN model, the other an RNN model. Both of these models use low-level audio features like mel spectrograms of a certain number of consecutive audio frames. Their architectures are briefly defined here. Both these models were benchmarked under a common protocol by Lee et al. In 2018. They have certain limitations, like because of the high parameter count, they have high inference and training times, as well as require huge memory and computation power. As such, they are not so practical from a deployment point of view. Model compression and knowledge distillation have been well-known techniques to address such issues. In this work, we focus on the latter. As the dataset, we follow Liator and use the Jamendo dataset, which contains 93 copyright-free songs, 61 for training and 16 each for validation and test. Following them, we also report 6 performance metrics on this dataset. Following Hinton et al., we briefly overview knowledge distillation. Here, a large cumbersome model called the teacher model is used to train a smaller student model to make it mimic the behavior of the teacher and achieve competitive results on a particular task. The overall equation is as follows. Here, LC is the usual cross entropy loss, whereas LKD is a KL divergence loss between the softmax probabilities of the teacher and student. Lambda and tau are two hyperparameters. To perform knowledge distillation with Schlatter CNN, we initially train a Schlatter CNN with the mel spectrograms, then its weights are frozen, and then a smaller student model is used with the original data as well as supervision from the original Schlatter CNN. The same scenario is repeated with the leg live RNN. Here only the data changes in place of the usual mel spectrograms. We have mel spectrograms of harmonic and percussive components. Following ensemble knowledge distillation as proposed by Hinton et al. Here we use the Schlatter CNN and Legline RNN as two teachers to train a smaller student CNN or RNN model. Here the softmax probabilities of the two teachers are combined by either their arithmetic or geometric mean, and the student receives additional supervision from these two teachers along with the usual cross entropy loss. As a result summary, we are able to outperform Slutter CNN using ensemble knowledge distillation on all the 6 performance measures. In case of leg live RNN, we are able to outperform it using simple knowledge distillation on 4 out of 6 performance measures. As our major contributions, we show that the optimal CNL model is more than 250 times smaller than the one proposed by Schlatter et al., whereas the optimal RNN model is at least 2.5 times smaller. Further reduction is also possible. Moreover, we are able to achieve state-of-the-art accuracies in the Jamendo dataset. These are our major references.